Hi, my name is Brianna Valderrama, and I will be discussing the atomic bomb experiment. So, of course, we didn't actually get to do the experiment because it's kind of hard to do, but we did watch that video that was provided to us. And from that video and just kind of other research that I found, atomic bombs are nuclear weapons that use the energetic output of nuclear fission to produce massive explosions. These bombs contrast with hydrogen bombs, which use both fission and fusion to power their greater explosive potential. Atomic bombs are made up of fissile elements such as uranium that is enriched in the isotope that can sustain a fission nuclear chain reaction. When a neutron hits the nucleus of a fissile atom like uranium 235, the uranium actually splits into two smaller atoms, which is called a fission fragment plus more neutrons. Fission can self-sustain because it produces more neutrons with the speed required to cause new fissions. This creates the chain reaction. The uranium-235 content of weapons grade uranium is generally greater than 85% through inefficient weapons deemed as weapons unusable. It can be made up of actually 20% enriched uranium. The very first uranium bomb was actually called Little Boy. It dropped on Hiroshima in 1945, and it actually used 64 kilograms of 80% enriched uranium. In fission weapons, a massive fissile material, either enriched uranium or plutonium, is assembled in a supercritical mass, the amount of materials needed to start an exponentially growing nuclear chain reaction. This is accomplished either by shooting one piece of subcritical material into another, and this actually is termed as the gun method, or by compressing a subcritical sphere of material using chemical explosives that has too many times its original density, called the implosion method. And I'm going to go into what the implosion method is exactly. So the implosion method is considered more sophisticated than the gun-metal and only can be used if the fissile material is plutonium. The inherent radioactivity of uranium will then release a neutron, which will bombard another atom of uranium to produce the unstable uranium-236, which undergoes fission. It then releases further neutrons and continues the process. The uranium atom can split any one of the dozens of different ways. If the atomic weights add up to 236, that means that the uranium plus an extra neutron is being combined. There are two methods that have been applied to induce the nuclear chain reaction that produces the explosion of an atomic bomb. The gun type assembly uses a conventional explosive to compress from one side, while the implosive assembly compresses from all sides simultaneously. The immediate energy per atom is about 180 million electron volts of the energy produced, and 93% is the kinetic energy of the charged fission fragments flying away from each other, mutually repelled by the positive charge of their protons. This initial kinetic energy imparts an initial speed of about 12,000 kilometers per second. However, the charged fragment's high electric charge causes many inelastic collisions with nearby nuclei, and thus these fragments remain trapped inside the bomb's uranium pit. Here, their motion is converted into X-ray heat, a process which takes about a millionth of a second. And by this time, the material in the core and chamber of the bomb is several meters in diameters and has actually been converted to plasma at a temperature of tens of millions of degrees. This X-ray energy produces the blast and fire, which are normally the purpose of a nuclear explosion. I thought it was actually quite interesting to learn about nuclear bombs, especially because it is a very well known um, bomb, especially throughout the years. It has been used in wars. And I think better understanding how it works and what goes into the nuclear bomb helped us allow to see what exactly is such the big fuss about it. I mean, especially because it can cause so much damage and it's known as such an explosive device. It is quite interesting that everything that goes into it, especially the uranium, and how like an extra neutron can change such a reaction. And I just want to say thank you for letting us learn about it, and I hope you learned a lot.